this one is view basic props. So we're going to continue. We're going to pick up from the last one we did, Eduardo and I, simple view. And so if you want to understand how we got where we're going to start, then go look at that challenge. But I'm just going to jump right in. So this one adds props into the equation. So we still have data, we still have computed, we still have methods. And I'm just going to paste in, we have to call it view basic props, but I'm just going to paste in what we had before, and maybe we'll build on it and see if we can add to it. So Eduardo, what are props in view?
Props are like the parameters or argument or function for components. Anything that should come from the outside to give information to the component on how it should render is usually a prop.
Okay.
Not all the time, but usually.
Great. And they have a type field, is that right?
Yeah, usually they have a type field, a require. They can also have a validator.
Oh,
and
interesting.
They have a default value, optional default value.
Oh, wow. That kind of reminds me of back in the old days, React had something like this called prop types.
Yeah.
And I always wished, it's interesting to say, I didn't know that they have validators. That's really kind of cool. Prop types never really had, they were validators in the sense that they could validate the type, but can you say can you make a validator in Vue to validate that a string is an email or something?
Yeah, you can write any function you want.
Wow.
It's a dev-only feature though, because it does incur some performance cost.
Yeah. Okay, cool. So I'm going to add that in the top here. For anyone watching, it doesn't actually matter what order these things are in because they don't get passed. We're not passing them directly. They're all inferred. So we could put these in any order, but anyway. And then let's add in props. And let's see what's happening. So if we go up to the top, okay, so we'll look at type. We're looking at 1a up here. It says this type of this dot prop a is supposed to be supposed to be any. Instead, it's true because this is an error. Does not exist on type. Okay, so the props need to be added to our this type, I think is what we're seeing there.
Yeah.
So we can put it here. Is that gonna work?
You probably want to look up data with these void.
Oh, interesting. Okay.
You can put the props instead of not exactly the props, but something that's going to transform the props.
Okay, let's come back. Okay, so methods and computed this type data. So to do that, do we need to grab the values of the things that the computed properties returned though, right?
Yeah.
Got it. Okay.
So these are a bit more complicated because you do have quite a few types and you're working from constructors and you have to generate the TypeScript version of the constructor.
So I'm going to build a simple little guy here that, wow, it's so nice to have someone on the line that knows about all this stuff, because then we can, I can just ask you the question and you know immediately how it works. So it's really cool. So we're going to grab the return type. And if the value, I guess we can make, there's newable objects here as well. Constructors, yeah. So we can just grab them like that, I suppose. We could call it C or whatever. It doesn't, for constructor, it doesn't matter. And then, I don't know, we'll just leave it as any for now. So that will grab us out the values of the computed things. Now we need to, I think we need to grab them from the object, from like computed object itself. So like what I kind of, from the props, yeah. So I kind of want to be able to say like, I want to be able to put it like that. So, okay, so we have that to work towards. So we have our mapping. We have, did I spell something right? Oh, I have to put an equal sign. Okay. So we're going to check if the value at any particular position has that type of the things that we were looking at. So because that's like string and Boolean, and I guess it can be an array. So let's handle an array as well.
First without the array. But you handle it right away.
how does that work with it? If you say array, string, or number, it means it could be either one?
It could be either one, yes. Both
Got it.
are accepted.
Okay. So read only, unknown array. Oops. So okay, that's easy enough. So we're gonna check if it's a tuple. So if it is a tuple, so we have to recurse.
Yeah. Oh yeah, you can also repass it. Wait.
So we'll just do result number to get all. So result number gets all the values of the thing inside the tuple. So that will make it like a union. But otherwise, we can just pass the result itself, and then we have to have a base case of recursion here. We'll do the same thing. We'll just pass in our value. Okay. So did we fix it? No, we didn't. Not
you
yet.
didn't. You did fix the methods though.
Oh, right. Okay. Cool.
You need to pass it. I think you've done if you pass it to the data on line 103.
Or 104, you mean? Or
yeah, there instead of void, if you pass.
Oh, okay. So we have to say prop types like that. Oh, yeah. Okay. Very nice. Okay, because data. Oh, interesting. Okay, so data is like the entry point for the component, and it's the thing that gets the props.
Yeah, you can access the props within data to instantiate the initial state. It's again not that common, but it is a feature that comes in handy in some specific scenarios. Differently from the methods, which now that I think again, I'm not even sure if you can access methods in the data. I think you can, but it's not useful. Whereas props, it's intended to work because in some scenarios you do need that for the initial state to be formed.
Got it. But computed properties. Oh, I see. So computed gets something from data. Computed doesn't get props directly.
No, you can access the same as methods in computed. The data, the method, the computed as well. So that's the other tricky part. You need to. No, you don't need to because it's handled by this type, I think. But you need the computed, you need the this type of data, methods, and props type.
Oh, okay. That's interesting.
Although you don't have any test, I think, but it doesn't seem to have
this is the end. This is it's all they ask us to do, so we can go home, But this is cool. I mean, how close is this to? I mean, so there's that thing you just said, but how far away is this from what it looks like in the view code base? Do you know?
Quite far.
Quite far. Okay.
Yeah, it's a bit unreadable, I would say. It depends on the versions. It gets more complicated, I think, with time because we recently had generics appearing.
Got it.
I haven't even wrote these types, to be honest, but I read them.
It's cool at least maybe to see like a simplified high level view of like what the types are trying to accomplish. Maybe.
Yeah, it is, and also the prop types with the union on the recursive type using a union by passing a number to get every tuple value.
Oh yeah, have you seen that before?
I used it sometimes, but it's again the kind of thing you use it very, very how do you say, like only not very often. Like I forgot the word in English.
Yeah,
but sporadically.
Yeah, I don't know if you have /. So we're on a VS Code live share right now for everyone watching. People can see, if you hover over X, people can see it. But just to show people what we're talking about is this. So if I have a type, like here's a type right now, it has a string, it has a number, and it has a Boolean. You could ask like, how do you get a TypeScript type that's a union that represents all of the things that are inside of my tuple? And the way you would do that is by, like if I put 1 here, for example, it knows that the value is 1. If I put 0, it's going to know that it's ASDF. So TypeScript knows what's inside of this because it's a tuple. It's hard-coded somewhere in the source code. I could put 2 and it would be true, right? So how do you get all of those things together? And the way that you do that, well, do you notice anything? What I'm putting here are all numbers. I'm putting 0 or 1 or 2 or 3. So what do those have in common? Their number. So the way in TypeScript you represent that to get a tuple out of all of the things inside, or to get a union out rather of all the things inside of a tuple, is by accessing with number, which is exactly what we did here. Because we're covering the case where on line 12 you could pass in string or number. Because this is, of course, Vue was written before, like originally was not made in TypeScript, right?
Yeah, there was no TypeScript at the time it was written initially.
Great. So yeah, that's why a lot of these things, and it was the same with React. Like React had a very similar system back in the day. Before Flow existed, React is not in TypeScript either, but it's basically the last large project that is not written in TypeScript known to mankind. But oh well.
Well, Svelte is also in JavaScript.
Which one?
Svelte is also written in JavaScript.
Oh, really? I didn't know that.
Yeah.
Oh man, what are they doing?
They do use the TS doc for TypeScript just to avoid the compiler.
I guess ESLint is also not written in TypeScript, but I hope they changed. I hope they changed their tune on that. Cool. Okay, we can move on to the last one. This was really fun. Do you have any other thoughts?
No, I think no. This is. I didn't remember the constructor one, the new and then infer from the return type. But again, this is the kind of things you write. You never almost write them, so you forget. You use them once and then you forget.
I think this is actually the first time in the challenges we've actually needed to do this constructor thing. So yeah, you're right. It's read only code. You write it once and that's it forever.
Read once.